Before we can solve trig equations and simplify trig expressions, we need to get familiar with some trig terminology. And the first is standard position. Standard position is just a way to describe the size and orientation of an angle on the Cartesian grid. So when something is in standard position, there is an initial arm and a terminal arm. So if we look at the following diagram, the arm that is on the positive x-axis is called the initial arm. And the terminal arm is the one that rotates around the Cartesian grid. So this line over here is the terminal arm. And the terminal arm can be anywhere. So we can have a terminal arm here, or in quadrant 3, or 4. And it can just rotate around the grid as much as it wants. Now, when we draw angles, we can have positive or negative angles. When you have a positive angle, you are starting on the positive x-axis, but your terminal arm rotates counterclockwise. So this right here would be a positive angle. Or if I'm in quadrant 3, this would be a positive angle. For a negative angle, you are again starting on the positive x-axis, but you are rotating clockwise. So this right here would be a negative angle, and that would be maybe negative 30 degrees. Or I can rotate into the quadrant 3, and this angle here is a little bit over 90, so maybe negative 120 degrees, and so on. So let's practice drawing some angles in standard position. And the first one is 45 degrees. Now maybe you want to draw a little reference. So here's 0, 90, 180, 270, and a full rotation is 360. So if I want 45 degrees, I want to be halfway between 0 and 90. So that would put my terminal arm here. And this angle here is 45 degrees. If I want to do 120 degrees, I have to be between 90 and 180, but a bit closer to 90. So maybe something like this. And that will be 120 degrees. Now let's try some negative angles. We have negative 45 degrees. So I'm going to write a new reference for our negative angles. Here's 0. Then we have negative 90, negative 180, negative 270, negative 360 if I'm going in the clockwise direction. So if I want negative 45, I'm going to go 45 degrees clockwise from 0, which puts me somewhere here. That is negative 45 degrees. And now let's try an angle that is greater than a full rotation, and that is 420. And it is positive, so I am going to go counterclockwise. And now here's 90, here's 180, 270, 360. If I add on another 90 degrees to 360, I get 450. So I know I'm not going to go all the way to that vertical y-axis that is positive. I'm going to go maybe from 360 to 420, that's 60 degrees. So it will end up somewhere here, and this will be 420 degrees. So it's a full rotation plus another 60 degrees. So it still ends up in quadrant 1, but it has rotated a full circle once. Now, wherever you draw your terminal arm, you can always create little triangles out of it, and that's going to be important later on. So I'm just going to look at example B, and I can draw a right triangle in there. So from this right triangle, I can set up any trig ratio for 120, sine 120, cos 120, tan 120. And I can do it for the 45 as well. And I drop down and I create a right triangle. Or let's say that negative 45 in quadrant 4. I can create a right triangle. Now notice in all of these scenarios, my right triangles are created with the x-axis. You will never draw a triangle with the y-axis. That's important to note for later on. But let's move on to another key word, which is coterminal arms. And coterminal arms are angles whose terminal arms have the exact same standard position. To get a coterminal angle, all you have to do is add or subtract another rotation. So let's look at 80 degrees. I'm going to start off with drawing 80 degrees. It would look something like this, and that is 80. If I just take this 80 and add on one rotation, I'll be back at 80 degrees. So I can add 360 to 80 to get a coterminal angle, and that angle will be 440 degrees. So 80 degrees and 440 degrees are in the exact same standard position. But I can also get a negative coterminal arm. From that angle, I can rotate in the other direction, so subtract 360. So if I do 80 subtract 360, I get negative 280 degrees. So both of these angles, 440 and negative 280 degrees, they're the exact same angle, just different rotations. And I can add or subtract 360 degrees however many times I want. And now let's try one more example. If you'd like, you can try this example on your own and pause the video and then come back to check your work. But 120 degrees is going to be somewhere here between 90 and 180. So this right here is 120. If I want a positive coterminal angle, I will add a full rotation. So I will add 360. I could add 360 once or twice, 3 times, however many times I want. So one option will be 480 degrees. If I want a negative one, from this terminal arm, I'm going to subtract a rotation. So I'm going to subtract 360, and I get negative 240 degrees. And those are coterminal angles. Now, the next rule that is very, very important for when we start solving trig equations and simplifying trig expressions is the Castrol. And we're just going to do a mini investigation, and then we'll talk about what this rule actually gives us. So in this grid here, I have my x-axis and my y-axis, and these are just 4 different terminal arms. So I have this one in quadrant 1, this is in quadrant 2, quadrant 3, and quadrant 4. Now with each terminal arm, I've drawn a vertical line straight from the top of the arrow to create these triangles. And all 3 triangles are the same, which means all the angles inside the triangle are the same as well. And I'm just going to label each angle as alpha. And I'm going to find all 3 primary trig ratios, sine, cos, and tan, in each quadrant, and then I'm going to make some observations. So let's start with quadrant 1. And from that alpha, 4 is opposite, 3 is adjacent, and 5 is hypotenuse. So I'm going to go ahead and write my sine alpha. Sine alpha is opposite over hypotenuse, so that's 4 over 5. Cos of alpha is adjacent 3 over hypotenuse 5. And tan of alpha is opposite over adjacent, so 4 over 3. Okay, so that's quadrant 1, nothing fancy. This is looking like grade 10 right now. Let's do quadrant 2. And now notice in quadrant 2, we do have some side lengths that are negative. The negative 3 in this scenario, which is adjacent, is negative, and that will impact some of our ratios. So again, I'm going to label 4 is opposite, negative 3 is adjacent, and the 5 is the hypotenuse. So sine alpha is opposite over hypotenuse, so 4 over 5. Exact same as before because it's the exact same triangle, pretty much. Cos alpha is adjacent over hypotenuse, so negative 3 over 5. And finally, tan alpha is opposite over adjacent, which is 4 over negative 3. Notice, in this scenario, 2 of the ratios are now negative. The only one that isn't is sine. Okay, so let's go to quadrant 3. And in quadrant 3, from alpha, negative 4 is opposite, negative 3 is adjacent, and 5 is the hypotenuse. So sine alpha opposite is -4 over hypotenuse is 5. So this one's negative this time. Cos is adjacent -3 over hypotenuse 5. So that one's negative as well. And tan is opposite over adjacent, which is -4 over -3, but we know two negatives make a positive. So in this quadrant, sine and cos are negative, but tan is positive because of the double negative. And now let's go to quadrant 4 and set up our ratios and make one final observation. So here from alpha, -4 is opposite, 3 is adjacent, 5 is hypotenuse. So sine alpha, opposite -4, 5 hypotenuse. Cos alpha, adjacent is 3, hypotenuse is 5. And tan alpha, opposite is -4 and adjacent is 3. And if we look in quadrant 4, the only ratio that is positive is cos. So the Castrol, notice C for cosine, A for all, S for sine, T for tan, tells us where each ratio is positive. So if we just look at our observation, in quadrant 1, they were all positive. In quadrant 2, sine was positive. In quadrant 3, tan was positive. And in quadrant 4, cos was positive. And there's your Castrol. Okay, so to label our Castrol on a grid, we start in quadrant 4 and then write in cast, C-A-S-T. And that will tell you what ratio is positive in which quadrant. Now, I am also just going to label quadrant 1, 2, quadrant 3, and quadrant 4. Now, if we have the exact same triangle in each quadrant, the ratios will be identical, except some will be negative and some will be positive. Now, let's say this right here is my triangle, and that is my alpha. And I'm going to draw the exact same triangle in each one, which means they all have the same alpha as the reference angle. But we know that in standard position, the angle starts at the x-axis and goes to the terminal arm. So in quadrant 1, we start at the x-axis, we hit our terminal arm, and our angle is actually that alpha. But when we go to quadrant 2 and we start at the positive x-axis, it's more than alpha. So in order for us to actually figure out this angle measure that I drew in here, it's pretty much reaching 180, except we're taking that theta or that alpha out. So our actual angle can be written as 180 subtract the alpha. When we're in quadrant 3, we're rotating and then we're passing 180 and we're adding on the alpha. So in quadrant 3, we're doing 180 plus alpha. And in quadrant 4, we're pretty much doing an entire rotation. I'm almost getting to 360 minus that alpha. So in quadrant 4, our angle is 360 subtract alpha. And this Castrol and these quadrant modifications are going to be very important for us when we start solving trig equations. Now that we have the Castrol, let's figure out some reference angles. Now these alpha that I drew inside each triangle, these are your reference angles. It's the related acute angle. So alpha for acute. Now let's practice figuring out the related acute angle. So I have 4 angles here. I want to draw them, and then I want to determine the reference angle or the related acute angle. So I'm going to take this 135. I know it's between 90 and 180, so it will be somewhere in quadrant number 2. Now 135 is this angle here, starting at the positive x-axis and reaching the terminal arm. The related acute angle is this angle here that is sandwiched between the negative x-axis and the terminal arm. It's the angle that would be inside the right triangle if I were to draw in that vertical line. So alpha will be the angle measure that needs to be added to 135 to reach 180. So if I want to figure out alpha, I can do 180 subtract 135, and I get 45 degrees. And to do a double check, I'll just add 135 plus 45, that's 180, and that's perfect because that's where the negative x-axis takes us. Let's try 150. 150 again is going to be in quadrant 2, a little closer to 180. 150 is this angle here, and the related acute angle alpha is this little angle here. And again, I want to figure out that leftover angle that I'm going to add to 150 to get to 180. Maybe you already know it's 30 degrees, but you can also show it by doing 180, subtract 150 to get 30 degrees. Now, the whole purpose of these related acute angles is that the ratio of sine cos tan of, let's say, 30, it's going to be the exact same ratio as 150 degrees, except one of the ratios will be positive and the other two will be negative, depending on what quadrant you are in. So let's try the last two. So 240 degrees will be somewhere in quadrant 3, right here. This entire angle is 240 degrees. My alpha is this little angle here that would be created if I drew a right triangle. So it's the angle that has to be added on to 180 to get to 240. So I can figure out alpha by doing 240 subtract 180, and our alpha is 60 degrees. And finally, 315 will be in quadrant 4. So this giant angle is 315, and my alpha is inside if I were to draw that right triangle. So it's pretty much the angle that has to be added onto 315 to make that full 360 rotation. So if I want to find alpha, I can do 360 subtract 315 to get 45 degrees. Now, identifying this reference angle or related acute angle will be really, really important for when we are solving trig equations later on.